Myself Nagamani. Welcome to my channel. Today we are going to learn what is echelon form of a matrix with an example. Okay. So most of the people having so many doubts like why we have to interchange the rows and what is the use of finding the rank of the matrix, or why we have to solve the matrices problems. How these problems will help in our real life. So these all these doubts will I will explain you in this class. Okay. And today, before going to start these, just go through once the definition of echelon form, or you can say that the steps we need to follow for solving the echelon form of a matrix. Actually, why we have to learn this? Because whenever they are giving any matrix, they are asking to find the rank of the matrix using echelon form of the matrix. So for converting given matrix into echelon form of a matrix, we have to know that how echelon form looks and what conditions it follow. Hmm? The For that we have to know these steps. Okay, just to go through once, I will write an example. With the example I will explain you so that you can understand easily. Okay. Okay. I hope my writing is clear to everyone. Okay. Just see once, like if we I have written one matrix, we don't know that whether it. I'm telling that it is an echelon example for echelon form of the matrix, but we don't know whether really it is example for echelon matrix or not. I have written randomly. Hmm? So if you see here definition, if a matrix is said to be echelon form if it follows all three statements, all three rules or conditions, statements, anything you can say that. If you follow these three conditions, then the matrix is said to be echelon form of a matrix. So if you see here, first one is all the zero rows occur below non-zero rows. First statement is that all the zero rows occur below non-zero rows. So if you see here I have written one example. So we will give you a name it as A matrix. Okay. If you see this A matrix here, there are four rows. Okay, four rows. This if we will define the size of the matrix. Here there are number of four rows and five columns. So this is 4 by 5 matrix. Okay. If you see here, first we will see how many non-zero rows elements are there, how many zero rows are there. If you see here, first is here it is telling that all the zero rows occur below non-zero rows. First we have to know the what you mean by zero rows. Okay, a row which having complete zero elements, then that row is said to be zero row. Okay, so if you see here there are other than zero, there are so many numbers are there. So which is non-zero row, and here this is also non-zero row because it having 1 4 2 5 numbers other than 0, and here also we are having 1 4 8 numbers. And if you see the last row, here we have complete 0 elements, so we can say that this is a 0 row. Here telling that all the 0 rows occur below non-zero rows. That means here all the non-zero rows, this is the 0 row, so this 0 row should be below the non-zero rows. This is the first condition. So if you see here, this first condition is satisfied here. Okay, and next one we will see the first non-zero element in each non-zero row is 1. That means if you see all these three rows, first entry of the row should be 1. Here it is telling that first non-zero element in each non-zero row is 1. So we have clarified, we know that these three are first R1 and R2, this is R3, R3 non-zero rows. So here telling that first entry other than 0, here the first entry is 1. So here telling that the first non-zero element in each non-zero row is 1. So here also applicable 1, and if you see row 3 also, it's satisfying 1. Okay, so that means every row is satisfying the second condition also. Okay, next one is number of zero rows before the first non-zero element in a row is less than the number of such zeros in the next row. Here what I will explain you in simple way. Here it is telling that here there are number of 4 rows are there. Okay, 4 rows are there. So if you see here, first row there is no zero. So we here row 2 and row 3 having more zeros. So we compare R2 and R3, and also we will see R4. Okay, R2. In R2 how many zeros are there? Only 1 zero. So we will count how many zeros? 1 zero will see. In R3 how many zeros are there? 2. R4 how many? 5 zeros are there. So here it is telling that if we write in here which is R2 which having less than number of zeros of R3 row, and also if you see here R3 row which having less number of zeros compared to R4. Here also like it is saying that number of zeros before that first non-zero element which should be less than the number of zeros in the next row. Okay, that means R2 is less than R3 or R3 is less than R4. Here also it is satisfying the number of zeros are less than the next rows zeros. So here condition 3 rule 3 also applicable. That means it's satisfying all the 3 statements or rows or conditions. So that means we can say that the given matrix is in an echelon form of a matrix. Okay, this is in these 3 steps we can confirm that we like whatever the final matrix will solve will got the whether the echelon form of a matrix or not. You can say simple in simple way you can identify that it's like an upper triangular matrix. And given just for identification or remember purpose only. You can't say that row echelon form is an upper triangular matrix. Okay, and this is the definition for it, and I will explain the example now. Okay, and if you want to take a screenshot of this class, you can take a okay. Okay, next I will explain it. Okay. Okay, I wrote the problem here. I hope it is clear to everyone. And one more thing I forgot to tell you is here. We have seen for a given matrix into how to convert the echelon form of a matrix. But we have to know the definition of how to find the rank of the matrix. That is the question mark now. So I'll explain you here. So in echelon form of a matrix, the rank of the matrix which is equal to the rank of any given matrix which is equal to the number of non-zero rows, number of non-zero rows of that matrix. Okay, rank of a matrix which is equal to the number of non-zero rows of that matrix means the number of rows non-zero rows of a matrix or here a matrix. Okay. This is the definition. Now we will convert this given matrix into the echelon form of a matrix. Okay. Now we will start solving this problem. Okay. For that, firstly, as per definition of echelon form of a matrix, we have to convert these non-zero row element of each non-zero rows of, we have to convert these elements into 1. Okay, for that we will see the one row operation. First we will convert first row R1 tends to R1. If we divide with this 3 by 3 only, then it will get 1. That's why I am dividing this complete R1 row by 1. Okay, R1 tends to R1 divided by 3. If you see here means that first row is R1 divided by 3 by 3 is 1 and 1 by 3 here, and here 4 by 3. Okay, next one we will keep it as it is, 0, 5, 8, minus 3, 4, 4. We are not changing any row 2 and row 3 operation. We are changing the only row 1. That's why I have written row 2 and row 3 as it is. Okay, this is the first operation we have done. So if you see here, for that, first we will try to, here we have already 0 element. If we can't convert this as 0 element with the help of R3 or R2, because if we want to change any row operations with this, here the number will change. That's why we won't, now we won't disturb any row 2 operation. Now we will convert row 3 operations. Here, see here, with the help of row 1 operation, R3 tends to, we have to convert into this as 0 elements, because here already 1 0 is there. So we have to convert this into 0 row. Sorry, we have to convert below here this and this one as 0. Okay. If we see here, R3 is converted into R3 tends to R3. If we want to 0 here, what we have to do? Here already minus 3 is there. So if we add plus 3, then this element comes as minus 3 plus 3 is 0. So that's why we are converting using R1 operation. We are telling that R3 tends to R3 plus 3 times of R1. So actually, if you see here, we are already dividing with the 3, and here we are adding plus 3 R1. So what I am thinking, directly will be this one minute. Okay. Straight away, first we will convert these two element as 0 by using R1 row 1. Okay, R3 tends to R3 plus R1. Okay, R3 plus R1. So if we get A matrix as, there is no change in row 1 and row 2, so I am writing as it is, 3 1 4 0 5 8. Here R3 plus R1, so minus 3 plus 3, you get 0, and here 4 plus 4 plus 1 5, and here 4 plus 4, we get 8. So after converting row 3 operation into R3 plus R1, we got this matrix of 3 by 3 matrix. This is the good practice of writing the size of the matrix. Okay, and if you see here these two rows are same. So with the help of R2, we can convert R3 as 0. So if I am writing here row operation, R3 tends to, we will convert R3 minus R2. Okay, if we apply this operation, we will see here what we will get. I am writing here directly. There is no change in row 1 and row 2 operation. We are only converting row 3 operation. And one more thing, first of all we have here, first of all we have to convert this element into 1. For that I am telling row R1 tends to R1 divided by 3. Similarly, and R3, row 3 is tends to R3 minus R2. Then only we will get 5 minus 5 is 0, and 8 minus 8 is 0. That's why R3 you are converting into R3 minus R2. These two row operations we are using here. So first I will write here, one thing is R1. So R1 is R1 divided by 3. So what we will get, 3 by 3 by 3, 1, and here 1 divided by 3, 1 by 3. Here we will get 4 divided by 3, because this is the R1, this R1 divided by 3. So 3 by 3 is 1, we got 1 by 3, and 4 divided by 3 is 4 by 3. Okay, next there is no change in row 2 operation. That's why I am writing as it is. 0, 5 and 8. We can add direct one more operation. We want to convert this element also directly 1. So we will write here R2 tends to R2 divided by 5. If you want to get 1 here, we have to divide 5 divided by 5, then we will get 1. So I am writing here directly R2 tends to R2 by 5 by 5 is 1, here 8 by 5. And R3 tends to R3 minus R2, here R3 minus R2. So 0 minus 0, 0, and here 5 minus 5, 0, and 8 minus 8, 0. This is the final matrix we got. Because we can't convert this row using R1, because if we convert this element into 0, then here this element will disturb. So that's why we want to get 0 in starting. That's why we can't do any more row operations. So this is the final matrix after row operations. From here we can find that what is the rank of the matrix, as we understood that rank of your given matrix, which is equal to the number of non-zero rows. So if you see here how many non-zero rows are there? Here 3 rows are there complete. In that one row is 0 row. So non-zero rows are 2. So the rank of given A matrix, which is equal to the 2. In this way we can find the rank of the matrix. Okay. Now I will explain you the what is the usage of these matrices or echelon form or rank of the matrix. Okay. Here with the help of these matrices, with these matrices which are help in real life problems as well as some engineering field like mechanical, civil, computer science, in any field, these matrices are useful for finding the problems. These matrices are helps in solving the system of linear equations. Why we have to find the system of linear equations? You will get that doubt definitely. So this system of linear equations which will help in while solving any structural type of problems. If you take any civil engineering topic, like whenever you go to the railway station, you just see the structure of that. There are so many trusses and the structure of that. In that, they will find the how much load it will take. These type of calculations will be done through the system of linear equations only. That system of linear equations needs to be solved with the help of matrix. It will be like it converts the complete complex system into very simple system. With this also we can find the how many solutions, number of solutions we can find, whether this system of equations which having constant numbers or it having infinitely many solutions, we can find through with the help of matrices. Okay. And also if you see in design field, uh, if you see any software, there are coordinates x, y, z coordinates. For that also, for defining this coordinate of the coordinates, they'll use this matrix itself. And I'll give one more example. Like in robotics, if you see the robotics, the movement of robotics also, which is defined by using these matrices only. So there are so many applications of matrices are there. So if you learn these matrices, it will be helpful for finding this. These are the applications of matrices and where we can use. And if you want more example, you can go through the internet, so that you will get so many lot of examples. And also in this way you can find the rank of the matrix using echelon form of a matrix. And I hope this class, like with this class, you got some knowledge. If you feel this class is useful to you, and if you feel that at least you will get some knowledge, please like, share and subscribe to my channel. And if you have any doubts, please comment below. I will definitely respond. and this is my first face-to-face interaction video. So if you find any difficulty like voice or the text size of this one or anything, just comment below so that I will go through that and I will rectify in coming videos.